In my math lab, there is a quiz, and it is not an actual quiz for us. It's not a grade. It's I'll look and see who did it, but as just kind of like a who's using their resources. But it's not. There's no extra credit involved. It's not mandatory. It is there for you to kind of like check yourself. Are you retaining 1, 1 all the way to 1, 4 so far? That's what it's for. So you can take it. If you are to take it, it's not going to hurt your grade because I changed it to no grade. So it'll say, oh, here's your grade, but it's not going to go into your actual grade in Blackboard. If you take it and you do poorly on it, it's a good checkpoint as, okay, maybe I've got some studying to do before this exam. The exam should be next week. It would be end of next week. That's the goal because we need to get another exam under our belt so that we have at least 2 exams in the grade book before fall break. You don't want to go into fall break with the only exam in the grade book, chapter R. So you need to be prepping for the exam. And when we get closer to the exam, I will give you all the info about it. You're not going to be in the dark. It is on my math lab. I'll explain everything. I'll explain how we're going to review for it and the expectations. Okay. So we only have 6. Yeah. Having said that, let's finish 1-4. We made really good progress yesterday, and we stopped just before the graphing calculator information. When you are going through the 1-4 homework, it probably felt doable, and you probably ended up in the word problems that I had not gone over yet. So you were doing the cell phone carrier problem. We're going to look at a word problem that will help you with that question in the homework. Refresh. Oh no. I can't refresh because remember it crashed yesterday. Anyways, we learned the value of point slope form and how it can save time if you are given 2 points and you can find the equation of a line. We talked about parallel lines have the same slope, perpendicular lines have negated reciprocal slopes. Given some lines, asked to determine if they're parallel, perpendicular, or neither. You have to get them in slope-intercept form in order to read the slope. Given a line on a graph and then a point elsewhere, and asked to find a second line going through the point in a manner that would be parallel to the given line or perpendicular to the given line. We practiced that. Remember, the only purpose of this line right here is to get the slope from it, and then you're done with that line, and then that's how you finish the problem. All right, which brought us to this slide. If you look at this little box, it's got a summary of the stuff we've done. It's got slope formula, slope-intercept, point slope. Then this is Hoy-Vux right here. This is Hoy, and then this is Vux. The numbers right there are just the number where it's crossing those axes. We talked about parallel lines, perpendicular lines. This is summarizing the slope. You will have a formula sheet for the Chapter 1 exam. I'll give that to you as we get closer so that you can see what you do not have to memorize, what will be given to you. Hoy-Vux is not on the formula sheet, and understanding how Hoy-Vux helps you is also not, is not on there. So you will need to know Hoy-Vux, which brings us to this right here. You need to know that any given vertical line will be perpendicular to any given horizontal line. Any given vertical line will be perpendicular to any given horizontal line. And if you think about it, that's because there's a vertical, there's a horizontal, That's why they're always perpendicular. It doesn't matter where they are, right? This is really, that's the whole, I'm trying to move my vertical line right and left and my horizontal line up and down at the same time. Anyways, at any given time, if you drop a vertical and you drop a, like you draw a horizontal, they're perpendicular. Let's refresh you on Hoy bucks. Hoy, let's write it like this. In big letters, leave some space, come over here in big letters. Bucks. Okay. Hoy stands for horizontal lines have a zero slope, which means m is 0, and the equation of the line is always y equals the y-intercept. It's where it's crossing the y-axis. Vertical lines have an undefined slope, which means we have no value for m at all. It's not that m is 0, it's that m's not there. And the equation for any given vertical line is always x equals the x-intercept. Make sure you understand the difference between 0 and undefined. Totally different. 0 is a number. It exists. It means it's a horizontal line. Undefined means it's not there. It means that at some point in finding the slope, 0 appeared in the denominator of the fraction, which is a no-go, right? That's when you get an error on the calculator, which is why it's called undefined. It does not exist. So, big difference between the two. If I said to you, for example, if I said, here's the point, -1, 5, tell me the equation of the vertical line going through that point. If I say vertical, you should think, ooh, bucks. That means I need to only look at the x value, and it's going to be x equals, what is the x value? It's going to be -1. So the vertical line would be x equals -1. Just write vertical line. I don't have a lot of room, so I'm abbreviating. And the horizontal line, Hoy, y equals, it would be y equals 5. It's as simple as that. It's so simple, it makes people think they're doing it wrong. It is. If I tell you it's vertical or horizontal, it's a Hoy-Bucks problem, and based on what you're being asked to find, the acronym will tell you what letter to look at, and that's how you write the equation. Okay? All right, the next slide is where we're getting into applications. Especially if you've had like statistics before, line of best fit. Do y'all remember that? Line of best fit. If you were to collect some data, and the data, if you created like a scatter plot, you don't have to draw this. If you created a scatter plot, you know, and it looked like that or something, I don't know. You would ask yourself, is there a trend? And in this case, it looks like there might be a trend going in a positive direction, right? So you would find the equation of the line of best fit, where you're saying, let's just assume all these points do make a nice, pretty line. Where would the line be that would touch as many points as possible and kind of encompass the trend? And that's the line of best fit. And then you use the line of best fit as a predictor for future values. Since it has a trend, you can say, oh, well, what about this value out here? Well, according to my line of best fit, you know, it's going to land somewhere around there, give or take. So that's the whole concept behind line of best fit. Curve fitting is the same concept. You have data and you're trying to decide, first of all, what type of graph would fit the data, and then find the data, like find the graph. I'm not going to teach you how to find the curve from the points by hand. That is where we need to just all say a nice prayer and say thank you to the gods that created the graphic calculator, because it will do it for you. You have to learn how to type it in, okay? So that's what you're going to have to memorize, is how to type it in and find it, and the calculator does the math for you. Go with me? Let's go to the next slide. So looking at this example, was there? Oh, no. Okay. Looking at the next example, cost of the 30-second Super Bowl commercial. This is insane. The cost of the 30-second Super Bowl commercial has increased, and this is old data. Look at that, 2010 to 2015. Has increased $1.6 million from the year 2010 to the year 2015. Model the data in the table on page 52 with a linear function, then estimate the costs in 2018. So this is where the math like this is relevant, because if you run some big multi-million-dollar company and you want your company's face in the Super Bowl commercials, you need to project how much money you need to be ready to spend on that 30-second ad in the years to come, right? So this is why this math exists. The table, I put it on your paper for you. It's a little small. It's a little hard to see. So let me see if I can make this table. There we go. All right, so let's look at the information. In 2010, they're saying use that as your base, so that's your base year, so X is 0. It was 2.9 million in 2011, so 1 year after 2010, it was 3.1 million, and so on. That's how you read these points. So instead of doing years for the x-axis, because you can't do the years in the calculator, you can't change the x-axis, they calibrated it, calling 2010 the base year. This is like, I call it the base year, where X is 0, and then 2015 would be when X is 5. These are the Y values in millions. Now, if you were to put it on a scatter plot, it would look like this. I want you to get your calculator, and I'm going to show you how to do this. Look at your notes. Go to the next. Oh, it's a copy to the next page, didn't it? It did. Okay. Just go back. Go back. I'll change my screen. So your notes have what the screen I'm fixing to display, but that way, so you're not flipping back and forth. I'm going to change my screen. Okay. Here, I have typed everything for you, and I have screenshot the information to help you. So you don't have to write it down. You do have to memorize it. Now, you might look at it and you think, oh, Lord, there's no way. It's actually pretty self-explanatory. If you will practice it a few times, it's really not that bad, okay? The last time I did this was a year ago, and I still have a general idea of how to do it. Like, so it's not that bad if you'll practice it. There is one thing that I will make sure before we take the test, and that's that your diagnostics is on. Because if your diagnostics is off, it's not going to give you the right answer. So to do this, I have it typed right here. You're going to hit second. There's no button for it. We just have to find it in the catalog. Second catalog, which is the number 0. And then it helps if you'll push the button that has a D above it, which is right here, because it'll jump to the D's. And then scroll until you see diagnostics on. Turn it on. Now, I will walk you through that before we take this exam, so that you don't have to memorize that. All right, your diagnostics is on. Now, let's do the problem. we're going to enter, so in order for the calculator to tell me any information about it, we need to enter the data in the calculator. We don't have the equation of the line, all we have are points, right? If you go back to, or if you look at your paper, these are coordinate points. You have, I'm just going to write in the middle, you have 0, 2.9, you have 1, 3.1, and so on. Those are your points. That's what we're going to enter in what's called your list of x and y values. So instead of entering the equation and getting a list, we're entering the list, and we're going to tell the calculator to tell me the equation. Do you see the difference? Okay. So if you hit stat, which makes sense because we're fixing to do a statistics problem, and edit, that makes sense because you're fixing to change what's in there. Hit stat, edit. See, here's my list from last year. Mine's already in there. Is yours in there? I hope not. Shouldn't be. It should be clear. So the first column is your x. The second column is your y. Remember, for your x's, you are entering 0 to 5. You're not entering 2010. And you can see right here, this is where I'm telling you, this is a step you're doing, and this is where I'm just telling you that the x values go in L1 and the y values go in L2. That should be pretty common sense. After you enter the data, we're assuming we've not seen the scatter plot yet, so we want to look at it. So you want to view the scatter plot. You can do, if you look right here, I've given you the steps. So second, y equals, we need to turn our scatter plot on, and we're going to do zoom 9 because it's a statistics problem. So you're going to do second, see it says stat plot. None of our scatter plots are on. I can't view it unless I turn them on, so I'm going to turn number 1 on. Then you'll see some extra stuff that it's asking. You don't have to change any of that. This just means, do you want it a dot plot? Do you want it to be like a line? Do you want a bar graph? Do you want a box and whisker? All that. This will default to L1 to and L2. You should not have to change that ever. This is how do you want the dots. This is what color do you want it. It's all the extra stuff. The only thing you need to do is turn it on. Okay? So hit enter where it's on, and you can arrow down to confirm on state highlighted. And now we're going to hit zoom. Instead of hitting 6, which is when we were graphing lines, we're graphing a scatter plot. We're going to do zoom 9, statistics. Now you can see the scatter plot. It's a dot plot, right? This is where you have to think to yourself, what's the trend? Does it look like it's a straight line? Does it look like it's a quadratic curve? Does it look like it's a cubic? So what's the trend?
Straight line.
Straight line. Okay, so what we're going to do is we're going to tell the calculator, hey, I think I have a trend that would fit a line here. It's called a linear regression. Regression, if you think about it, it's like saying, hey, like force these points to fit the line that would like pass through the majority of them, okay? So right here, this, where it says view the scatter, I'm trying to simplify this. Where it says view the scatter plot, that is done by these steps, okay? And it was zoom 9 because that says stat. This is where it should be kind of self-explanatory. It's a statistics problem. Now we're going to calculate the linear regression. That is done by these steps. So when I say you have to memorize all these steps, there's really not that many. The arrows are the ones where you're actually doing something. The rest is me saying, now you go here. Now you need to do this. Okay, we're going to hit the stat button. Think about it. We've entered the data, right? We turned our scatter plot on. We saw it, right? Now we need to do something with it, which makes sense to go back to stat and then arrow over to calc. We're telling the calculator, all right, here's where I need you. Arrow over to calc, and if you will notice, there are all sorts of regressions, and that's for it depending on how the data looks. If you look right here, you see ln, reg, ax plus b. Then if you look at 8, you see ln, reg, a plus bx. Both of them are linear regressions. Which one do you think we need? Ax plus b. That's going to give you the coefficients m and b. Now, why they don't put an m there, I really don't know the honest reason why they don't use the m. But anyways, that's where they're going to give you the coefficient for m and the number for b, and then you just write the equation. So we're going to select for ln reg ax plus b. It's going to say, okay, you want me to calculate the line of best fit. I need you to verify where your x coordinates are and your y coordinates are. That should default to the list that you already have. You should not have to change that. Here's where you want, this is an extra, right? Okay, I'm going to show you like from here down. This is going to be an extra step to make your life easier. When this spits out the line of best fit, don't do anything on your calculator yet, just watch. Look at those numbers, right? They're ugly. Okay, if I want to write them on paper or if I want to type them in my calculator, I'm going to have to round at some point. Would you agree? When you round, especially y'all should notice in statistics, when you round, you're changing the data. Yeah? So we don't want to round until we absolutely have to at the very end. So this right here, store the line of best fit in y equals. There is a way to tell the calculator, hey, all that crap you're about to tell me, can you just go ahead and, if you don't mind, if you put it in y equals, that'd be great. You know what I mean? You're telling the calculator, take that mess and go ahead and stick it in y equals so I don't have to type it. Okay, so here's how you do it. Let me draw another arrow. This is the actual means to doing it. Now, you should be on this screen. Let me go back to it. That's the screen you're on, right? Scroll down to where it says store reg EQ. That means, where do you want me to store the regression equation? So scroll down. Oh, I went too far. Now here's where do we put equations and lines in our graphs in our calculator? Y equals. Okay. We want to be able to say, hey, I want you to put it in y equals. Now, you've got to think, in y equals, how many equations can there be? A lot, right? We want it to go in y1. You have to be specific. So, instead of just typing y1 here, it won't let you do that. You have to, this is the only part that's annoying, you have to go within the calculator and pull the y1 formula. And this is how you do it. There is a button called VARS on your calculator. It stands for variables. It's where all of the variables in your calculator are stored. And we're going to push, while the cursor was right there at store reg equation, we're going to push VARS. Now it's going to say, okay, what variables do you want? Well, we want it to go in y equals, so arrow over to y vars, and this is going to be a function. Enter on the 1, and then there they are, and you just hit enter, and it's going to now put it there, and then now go to calculate. So, two things have happened. It's going to spit out the equation, and now you can see if I was to write the function, what was it, Super Bowl ad? Was it based on time? It was time, right? Time after 2010. There you go. All right, so the cost of the Super Bowl ad based on how much time has passed since 2010, that was the base year. You have to be careful here. Remember, it's y equals ax plus b. A is your slope. So it would be 0.314x plus 2.848. I rounded there. That's what you would like write if I said, you know, or in the calculator, or what is it, My Math Lab. They'll tell you how to round it, and that's what you would type in. But now I want you to hit the button Zoom 9. Hit Zoom 9. Oh wait, I'm still on. Hit Zoom 9. What do you notice? Graphed it for you. That's the beauty of it. And it goes through what looks like the majority of the points. And if you go to y equals, well, there it is. It's right there. That mess. All of it. The whole mess. No rounded. It's all there. Okay. There is a word that goes right here. It's the line of best fit. So if you have a highlighter, I would probably highlight where you're actually pushing buttons on the calculator, because that's what you're going to have to memorize. During this exam, you cannot raise your hand and say, Miss Holcombe, I don't remember how to do this. You're going to have to memorize this. And it's really, like I said, it's really not, if you look at it from a standpoint of what you're trying to do, it's not that bad. You're telling the calculator what the points are first. So that would be going to lists. Then you're telling the calculator, hey, now that you've got the points, turn the scatter plot on so I can look at it. Then you're saying, now I'm ready for you to tell me the line of best fit. And while you're at it, stick it in y equals 1, y1 for me, so I don't have to type it. Okay? So that is the correlation coefficient, and that actually is, I think that's the next slide. Yeah, so let me just go right into the next slide and I'll tell you. You will not be asked that in a manner that your calculator doesn't provide it. I'm not asking you to calculate that by hand. I would just try to figure out why your calculator's not calculating. You'll be fine. Yeah, you should be fine. Correlation coefficient. You should recall this from statistics if you've ever had that. Basically, someone said, hey, we need a way to talk about when the data is all over the place, or when the data looks like it almost lines up right on the line of best fit. We need a way to talk about it that's not subjective, where you just say, oh, it looks really good, or it's all over the place. Like that's ambiguous. We need a clear, quantifiable way. Quantifiable means a number that tells me how strong is the data to the line of best fit, or how weak. Enter correlation coefficient. It's the R, or the R squared in your calculator that you saw at the very end. Is mine still up? No. Stand by. I'll pull it up. The correlation coefficient comes from, now why they did R, I guess because the word correlation has so many. Correlation coefficient comes from the the data based on the space of the points to the line of best fit. And it's kind of like an average. It's not really an actual average. I'm just trying to best way to explain it. If there's a lot of space between the points and the line of best fit, then there's a weak correlation. If the points kind of all fall in line on the line of best fit, there's a strong correlation. If you look right here, these all have positive slopes. These are all examples of positive correlations. Positive correlations. And then down here, these are all examples of negative correlations. Then if you look underneath the pictures, they're telling you what the actual correlation coefficient was. So like in this case, R is 1. Well, that makes sense because every point in that data looks like it's on the line. Here, R is 0.9. Here it's 0.4. Here it's negative 1. So what's the difference between these two? One's positive and one's negative. The one that's negative has a negative correlation, like this, it looks like it has a negative slope, hence the reason it's negative. And the points are on the line, so it's negative 1. This one is negative 0.9, this one is negative 0.4. So what did the correlation coefficient range from? Negative 1 to 1, right? And so what's in the middle of that? Go to the next slide. Correlation coefficient always falls between negative 1 to 1. If it is close to negative 1 or 1, there is a strong correlation, which means if you wanted to use the equation of the line of best fit to predict future values, you would probably be accurate in your predictions because of the relationship. If you have a correlation coefficient that is near 0, do you want to use the equation of the line of best fit for future predictions? No. It's a waste of time because there was no relationship, right? Perfect example would just be like if it's just all over the place. I mean, there is no trend at all. It looks like someone sneezed. Terrible way. That's how my son sneezes, my 4-year-old. But it looks like someone just sat there and just made dots with their eyes closed, and there's no relationship at all. This would be R is 0. Now, how do you get it? How do you get the correlation coefficient? You don't. Calculator does. This is another thing where you just rely on the calculator. And guess what? It's what you've already done. It's what's already in there. It was at the end of it. Did anyone, if everyone, let's just make sure everyone's, if y'all will hit stat, arrow over to calc, and select number 4. Then go down to calculate. Don't hit enter too hard, like too many times, because then the screen disappears. Tell me if your calculator is not showing you the correlation coefficient. if that were to happen during the test, like that's when you could, like Miss Holcombe is not, that's not saying Miss Holcombe, I don't know what I'm doing, that's saying Miss Holcombe, it's not working, something's not working. You do have to make sure your diagnostics are on or it won't calculate that for you. But that's it, okay? Now, in the homework, I don't remember what number it was, but I know several people were doing it yesterday and they were asking questions. It's the cell phone. You know what number that was? 8? Cell phone carrier? Alright. Let me give you an example that's slightly different. So this is for the My Math Lab homework. This is going to be an example that is not cell phone related, but it's the same concept. And I'm not going to type a whole paragraph out. I'm just going to give you bullet notes. Let's say you're going to go park a car in a garage in Atlanta. Okay, so first of all, there is a $10 flat rate for parking. I'm going to put it here. 10. There's a $10 flat rate for parking here. You're welcome. Then it's $3 an hour. I want you to write the function that would represent the cost of parking there based on T hours. Okay, so cost of parking, they named the function for you in the homework. The cost of parking based on T hours would entail what amount of money up front? 10, period. Like, as soon as you park in there, you're paying $10, right? $10. Now, in My Math Lab, you would not enter the dollar signs. You should know that. And means what in math? Okay. Now, what's the rate? So it'd be 3T. So this is your flat fee, and then this is your rate per T hours. That's the same concept that you're going to use in the My Math Lab homework, except it's a cell phone carrier. Back when, we used to have to pay per minute we talked on the cell phone. And per text we sent or received. Y'all think I'm lying or exaggerating. I'm not saying like, back when I was in school, I walked up the hill twice to get through the snow in the school. Like, no, this is serious. I'm being serious. We paid per minute to talk on the phone. We also paid per text. And the bad thing is that was sent or received. So if someone's blowing up your text phone because they got money to blow, you're like, dude, I'm paying every time you text me, quit. Except after 9 p.m. you could call for free. That was I'm not kidding. It was like 9 p.m. all calls were free. So that's when it was like, call me at 9. All the good old days. Anyways, if I said, how much would it cost me to park here if 6 hours had passed, you would just, what? With the 6. Plug it in. That's it. Read the directions in the homework. It will say where to round to. Okay? Trying to think of what the other one was. Boy bucks comes up a few times. Don't panic. Go look at our notes on boy bucks.